Well, hi everybody, it's the Phantom here. Today we're going to try to prove why is the formula for the square of binomial equal to a square plus minus 2ab plus b square, and why is the formula for the difference of squares a minus b times a plus b. So sit back and enjoy. And let's first start with the formula for square of binomial. Now, in each formula for the binomial square, you will notice that middle term is equal to the twice the multiplication of the terms used to create the binomial expression. But how can we prove this? Well, we can use a simple algebra, like a plus b square should be equal to a plus b times a plus b. Now, let's try to multiply each term individually. So, a plus b square must be equal to a times a plus a times b. Now, we can multiply b times a and b times b. So, as you can see, we get the following, that a plus b square is equal to a times a, which is a square, a plus b and a plus b together are 2ab, and b plus b is equal to b squared, and here we have it, our proof for the square of binomial. So if two terms in binomials don't have the same sign, so a doesn't have the same sign as b, the exact same formula will work, only we will switch the sign plus with the sign minus. And as you can see, we will get exactly the same result, only the middle term will have the negative sign. But now we have to wonder, is there any better way to do this? Is there a way that we can prove this with geometry? And actually, there is. Let me show you. So first, let's imagine that you have an apartment in the shape of the square. And let's say that you have 4 rooms. The biggest room is also in the shape of the square, with a length of a and a width of a. The smallest room is also in the shape of a square, with the length of b and the width of b. The third room will be the shape of the rectangle, with the length of b and the width of a, and the fourth room will of course have the length of a and the width of b. Now, let's say that for some reason you want to calculate the overall area of your apartment. The easiest way to do this is by simply multiplying the length of your apartment, which is a plus b, with the width of your apartment, which is also a plus b. That means that area of your apartment is equal to a plus b squared. Now let's do exactly the same thing, but this time we will use the sum of the individual areas of each room of your apartment. So we have the area of the first room, and that is a times a, the area of the second room, which is a times b, the area of the third room, which is again a times b, and the area of the fourth room, which is of course b times b. Now, overall area is equal to a times a, which equals a squared, plus a times b and plus a times b, that equals to 2ab, and b times b equals to b squared. Now we can switch the value of the area from the row 2, and we will get that a plus b squared is equal to a squared plus 2ab plus b squared, and this is our formula. Of course, exactly the same thing applies for binomial with the minus in the second term, because only thing that you have to do is to switch the value of b with a negative b, and the same rule will apply, and you will have a minus b squared equal to a squared minus 2ab plus b squared. And this is again our formula. Now, let's try to do this for the formula for the difference of squares. Let's try to prove this formula. We can just follow the same logic as before. So first, let's try to do this with algebra. So let's start with a squared minus b squared, that is equal to a minus b times a plus b. Now, let's check this by multiplying each term individually. So we get a times a, then we get plus a times b, then minus b times a will be equal minus ab, and we have minus b times b. Great, so this means that a squared minus b squared is equal to a times a, which is equal to a squared. We can cancel plus ab and minus ab, and we get minus b times b, which equals to minus b squared. And as you can see, we have proven this formula with algebra. But can we prove this formula with geometry like before? Yes, of course we can. So this time, let's say that we have a square, and the square has the length of a and the width of also a. Now let's say that the square has a hole, also in a shape of square, with a width of b and the length of b. Now let's try to calculate the area of this blue surface. We can say that area of the surface is equal to area of our big square, which is a times a, minus the area of the smaller square, which is b times b. So we get the area that equals to a times a, that is a squared, minus b times b, that is b squared. Now, let's do the same thing, but this time we will divide our surface into two separate rectangles. As you can see, we will have an orange rectangle, which will of course have the length of a, and the width must be a minus b. That rectangle will of course have the area of a times a minus b. Now we also have a small green rectangle with the width of b and the length of a minus b. The area of the small rectangle will then be b times a minus b. Now we can say that the overall area is equal to the area of the bigger rectangle, that's a times a minus b, plus the area of the smaller rectangle, that's b times a minus b. Now we can see that a minus b and a minus b are common factors, so we can put them in front of the brackets. So that's a minus b times, we have left with a and plus b, so that's a minus b times a plus b. As before, we will replace the value of the surface from the line 2, and we get a squared minus b squared, which equals to a minus b times a plus b. And there it is, our formula. I hope you guys enjoyed this one. If you did, of course, as always, give it a like, share and subscribe. It will mean a lot to us. And until next time, see you all guys. Bye.